Every passing second, more than 3,000 chocolate bars disappear from store shelves around the world. The only sweet powerful enough to satisfy a global craving and drive a $150 billion industry. But have you ever wondered how more than 5 million tons of chocolate are produced each year? The journey of sweetening the world begins in the cocoa forests of West Africa, where bitter, rugged cocoa pods are carefully harvested by sun-hardened hands. From there, they undergo a traditional, labor-intensive pre-processing stage before entering massive factories, where a series of intricate, high-precision steps unfold non-stop, based on secret formulas few people ever see. But in today's video, Agriculture Insight will unveil the entire process behind this sweet legend. What made chocolate become a global obsession? Everything will be revealed right now. Among more than 8 billion people in the world, 60% have tasted chocolate at least once. In the European Union, the continent most obsessed with chocolate, 70% of the population eats chocolate every day. Yet that number is nothing compared to the United States. In this land of Trump, more than 1.5 million tons of chocolate are consumed every year, and there is no sign of decline. What makes people become so obsessed with this sweetness? Very early, from 3,500 years ago, the cacao tree, Theobroma cacao, meaning food of the gods, a native plant of the central South American region, was harvested and used by the Olmec people. They ground cacao beans and mixed them with vanilla, corn flour, and even chili, creating a bitter drink that was revered treasure by the two great civilizations that followed, the Maya and the Aztec. Through many centuries of conquering the New World and expanding colonies, the Spanish brought cacao to Europe, adding a great deal of sugar to this drink, transforming it from a sacred ritual into a privilege of the aristocracy, and then spreading it across the world. The turning point that shaped the modern chocolate world appeared in 1828, when Coenraad van Houten invented the hydraulic press to separate cocoa butter, paving the way for the first solid chocolate bar in 1847. From there, the chocolate industry exploded with the rise of the empires Cadbury, Nestlé, Hershey, and Mars. Up to this day, this gigantic industry generates more than 130 billion USD each year, with 60 to 70% of the profit in the hands of the major corporations, yet only 5 to 7% of the value returns to the cacao-growing households in West Africa, the people who create the core raw material of the entire industry. And that is only a small part of the bigger picture of chocolate. Right after this, let's step into the real journey of creating the chocolate bars that captivate the world. Everything is only truly beginning now. More than 5 million tons of cocoa sustain the billion-dollar chocolate industry, mostly from West Africa, especially Côte d'Ivoire and Ghana. Yet almost all of it is still harvested by hand, because with rugged terrain, fragmented smallholder farms, and the delicate structure of cocoa trees, whose pods grow tightly against the trunk, mechanization remains limited. By September each year, cocoa plantations enter peak harvest season. Ripe pods are usually yellow, orange, or red, but green ones can still be cut because each variety ripens in a different color. To harvest, farmers use long, curved machetes, traditional tools that have existed for hundreds of years, and with a single precise cut, they can remove the pod without damaging the tree. In addition, specialized pruning shears are also used to handle pods that are lower and easier to reach. Meanwhile, for pods high above or hidden deep in the canopy, long poles fitted with curved blades at the tip are the perfect choice for cutting without climbing the tree. Freshly cut pods are gathered for the legendary step, bean extraction. Splitting a cocoa pod requires a sharp knife and just enough force to avoid crushing the beans. Inside, the seeds wrapped in tangy white pulp are scooped out by hand. A skilled worker can handle 150 to 200 pods per hour. That may sound low, but beginners often achieve only half of that, meaning an income of about $1 per day can be further split apart simply due to slower hands. The beans are then transported to processing sites. In some regions with muddy terrain and poor roads, donkeys are still used today as reliable means of transport. Crude and slow as it is, this land of scarce resources but abundant low-cost labor remains the backbone that supplies up to 70% of the cocoa for the global chocolate industry. And clearly, the journey of the calloused hands that sweeten the world is nowhere near as sweet as the final product they create. Cocoa beans, once they leave the plantation, cannot be used immediately and must undergo a fermentation process lasting 5 to 7 days, a step that determines 60 to 80% of the final chocolate flavor. Traditionally, the beans are fermented in layers of banana leaves, where heat and natural microorganisms trigger the breakdown of the mucilage, kill the embryo, and develop precursor aromas. Today, most cocoa is fermented in multi-tier wooden boxes that allow even turning and better temperature control. The ideal temperature throughout fermentation must stay between 40 to 50 degrees Celsius, with the bean mass kept aerated and not overly moist to avoid anaerobic fermentation. Crucially, the beans are turned once a day from the second or third day onward, a vital step to distribute heat and oxygen. Just one mistake, such as delayed turning or excess water, can leave an entire batch overly acidic, off-flavored, and severely downgraded. This is an irreplaceable link in the journey that transforms raw, sharp-tasting, fruit-scented cacao into premium chocolate. After 5 to 7 days of fermentation, when the beans have turned dark brown and release a characteristic cocoa aroma, the wet beans are brought out to dry under the sun for up to 7 days. This is a crucial step that reduces moisture from over 60% to around 7%, meeting storage and export standards. Farmers usually dry the beans directly on concrete yards or bamboo mats. In some areas, raised drying racks with roofs are used to avoid sudden rain. This stage also demands precision. The beans must receive enough sunlight each day, be stirred constantly to dry evenly, and kept free from moisture or mold. Just one damp spot can ruin an entire batch of cocoa. Once the cocoa beans reach the proper dryness level, they are sorted to remove impurities, flat beans, and low-quality fragments before being bagged and stored. After receiving confirmation from buyers or collectors, the entire batch is transported to the export port, ready to set off abroad, heading toward a dazzling world of precision machinery and polished production lines, the chocolate factory. Now, let's step into the most anticipated part, the chocolate production paradise of the world's most developed countries, where modern production lines dominate this billion-dollar industry. At the factory, cocoa beans, once received, must undergo a quality inspection before officially entering the chocolate-making process. A step that seems simple, yet is absolutely non-negotiable. After passing inspection, the qualified batches are sent straight to the cleaning area. Workers slice open the bags, pour the beans into the feeding hopper, and send each cocoa bean one step closer to its mission of becoming chocolate. And when everything is finally in place, the most crucial step to unlock the cocoa's true flavor begins: roasting. At bean-to-bar facilities or small-scale workshops, the most common choice is paddle-style roasters. Inside is a semi-closed roasting chamber where rotating paddles constantly toss the beans to ensure even heat exposure. This type of machine allows direct observation of the bean's color, aroma, and sound throughout the roast, while offering flexible temperature control from 100 to 140 degrees Celsius, adjusted in small increments with just a few buttons. The paddle speed can also be fine-tuned to suit different roasting styles, a major advantage for small batches requiring precise manual adjustments. In industrial factories, drum roasters with capacities of hundreds of kilos per batch are the optimal choice. After the beans are roasted, they move on to the next step, separating the shells to obtain the cocoa nibs. Large capacity winnowing machines can process hundreds of kilos of beans per hour, operating on the principle of cracking the beans and then using strong air currents to blow away the lighter shells while retaining the heavier nibs. A multi-stage sieving system further sorts the nibs by size, ensuring that only those meeting the required standards move on to the next stage. The next step takes the freshly separated nibs into the grinding system to create cacao mass, the foundation of the entire chocolate industry. First, the nibs are coarse ground using roller crushers to break down their structure and release the natural cocoa butter, gradually turning the mixture from solid particles into a thick paste. The mixture then moves into ball mills or granite stone grinders for deeper refinement, reducing particle size to just 15 to 30 microns. Heat generated from friction melts the cocoa butter, transforming the mass into a smooth, homogeneous cocoa liquor, the core ingredient that determines the silkiness, richness, and flavor profile of the final chocolate. A portion of the cacao mass is fed into a massive hydraulic press to separate the cocoa butter. Under tons of pressure, the melted cocoa butter flows out in a steady stream, while the dry cocoa cake is pushed aside to be ground into powder. A fun fact: chocolate melts in your mouth, but not in your hand, and cocoa butter is the secret behind that. The dry cocoa cake is then fed into a specialized grinding system to produce cocoa powder. High-speed grinders break the solid cake into fine particles, resulting in a light, fluffy cocoa powder with a rich aroma, an essential ingredient in confectionery, beverages, and chocolate production. And once all the core ingredients, cocoa mass, sugar, and cocoa butter, are ready, they are poured into an industrial mixer for blending, the opening step that defines the structure and flavor of the chocolate. First, the cocoa mass is stirred and warmed. Then, sugar and cocoa butter are added in sequence, transforming the mixture from loose, dry particles into a thick, cohesive crumb. The mixer continues to knead and compress the blend so that sugar particles become evenly coated with fat, forming a uniform pre-chocolate base. Once it reaches the proper consistency, the mixture moves directly into the conching stage, where chocolate is refined, aerated, and polished to perfection. Conching, the most critical refinement step in chocolate making. In this stage, the chocolate mixture is continuously agitated, ground, and aerated in conch machines for anywhere from a few hours to over 72 hours, depending on the desired quality. Heat and friction drive off acidic notes, smooth out harsh flavors, and allow cocoa butter to fully coat every solid particle, creating a silky texture. The process also deepens aroma development through oxidation and the release of complex flavor compounds. The result: chocolate with its signature smoothness, shine, and refined, well-rounded flavor. When the conching process is complete, the liquid chocolate is kept warm in controlled holding tanks to maintain a stable viscosity before moving into the molding stage, the final shaping step that determines the product's appearance. In modern factories, the molding process is almost fully automated. A conveyor system carries clean polycarbonate molds through a vibrating unit, after which liquid chocolate is precisely deposited into each cavity by dosing nozzles. Immediately after filling, the molds pass through a high-frequency vibrating table to remove air bubbles and ensure the chocolate spreads evenly, preventing surface holes or cracks in the finished product. Next, the molds enter a cooling tunnel set to a precise temperature range, allowing the chocolate to solidify and contract slightly for easy demolding. Once properly cooled, the molds are inverted and gently tapped by a mechanical system so the bars or pieces of chocolate fall onto the conveyor. From here, robotic arms or automated belts transfer the pieces through inspection, wrapping, packaging, and boxing. Every step runs seamlessly, cleanly, and accurately, completing the long journey from raw cacao to glossy, finished chocolate ready for the shelf. Pizza, a small circle, yet a powerful symbol of the entire fast food industry. It's often called an addiction flavored with oregano and tomato sauce, capturing the hearts and stomachs of billions across the globe every single day. You can find a $5 pizza baked in a brick oven on a Naples street corner, or order a $12,000 version at a luxury restaurant in New York, topped with caviar, truffles, and gold leaf. And while a pizza can be sliced into 8 even pieces, the battle for each slice of the market is far from evenly split. For decades, Pizza Hut reigned supreme with its classic dine-in restaurants, family-friendly ambiance, and broad menu. But since 2018, Domino's flipped the script, becoming the largest pizza chain in the US by revenue, thanks to its massive automation systems and highly optimized logistics network. The race is so fierce that even McDonald's, the global fast food titan, once tried to enter the pizza market back in the 1980s. But eventually, even McDonald's had to retreat quietly, unable to keep up with Domino's. So yes, pizza is more than just food. It's a global culinary icon where creativity, technology, and business collide on a single crispy crust. Which pizza is your true love? Drop a comment below and share it with me. And right now, join me on a breathtaking journey through endless wheat fields, the very beginning of those golden, crispy crusts that make the world fall in love with pizza. In June, across the states of Kansas, the wheat capitals of the United States, endless fields turn a brilliant shade of gold under the summer sun. It's a familiar signal. Harvest season has begun. Right then, the massive combine harvesters begin to roll. Each one stands nearly 3 meters tall, stretches over 10 meters long, so massive that anyone standing beside it looks completely dwarfed by the steel giant. Small in size perhaps, but still in full command of the entire harvest. At the front, a sharp cutting blade glides just above the ground, neatly drawing whole stalks into the machine. The leftover straw is returned to the field like a natural mulch, while the clean kernels are collected into an onboard storage tank. Each modern harvester can collect over 90 tons of wheat per hour, an astonishing figure, equal to the labor of hundreds of workers operating non-stop, leaving behind the bulky, complicated machines of the past that once dominated the fields. These days, farmers no longer have to bend over with sickles to harvest each stalk by hand. But that doesn't mean they have it easy. The fields today are more expansive than ever, stretching endlessly to the horizon, so vast that even a bird in flight might never reach the end. To make it more challenging, harvesting can only happen in the early morning or late afternoon, when moisture levels are just right to avoid cracked or damaged grains. That's why lunch often means a cold meal eaten in a hurry under the shade of a harvester, chewing between rows, eyes still watching the field bathed in golden light. Out here, every minute counts, and true rest becomes a rare luxury during harvest season. Then it's right back to the harvest. Grain tank is full, the wheat is unloaded directly into large trucks driving alongside the field, or a specialized truck drives alongside the harvester, receiving a steady stream of wheat pouring from the unloading pipe, all happening seamlessly, without the machine stopping for even a second. This synchronized and precise process helps optimize time, maintain ideal freshness and dryness, and preserve the grain's quality, minimizing post-harvest losses to the greatest extent. After being harvested from vast wheat fields, the grain is transported to a grain storage facility. Here, the wheat is unloaded into underground receiving pits. These are steel-reinforced pits, built directly beneath the receiving area of the facility. From these pits, the wheat is moved by conveyor belts or bucket elevators into large silos, towering cylindrical storage tanks made of steel or concrete. Inside the silos, the wheat is stored under strictly controlled conditions for humidity, temperature, and ventilation. Inside these seemingly empty metal ducts, tons of wheat grains are silently moving, weaving through every bend and corner, making their way to specific areas such as cleaning machines and moisture conditioning units within the factory. After being thoroughly cleaned and resting inside massive silos, wheat begins its next journey, heading to the flour mill. But instead of walking or hopping on a train, the wheat slides through enclosed pipes and industrial chutes. At the end of this slide, tons of golden wheat grains come rushing down into enormous trucks, each capable of carrying 25 to 30 tons, roughly the weight of 5 full-grown elephants. But don't think they can just hit the road right away. Before leaving the site, each truck must pass through an electronic weigh station, ensuring the load is within legal limits and recording the exact weight down to the last kilogram. This strict monitoring isn't just about avoiding overloaded trucks. It's also essential for inventory management and traceability. In the food processing industry, every grain of wheat must have its own identity papers. Inside the flour mill, after undergoing initial cleaning, the wheat grains are passed through an additional round of screening, this time much more meticulous. From the screening section, the grains are sent to a central distribution hopper system, where automated valves precisely control the flow of wheat into the next stages of processing. However, before they can be milled, the grains must go through large tempering tanks. The wheat is lightly moistened and left to rest for 12 to 24 hours. This softens the outer bran layer, making it easier to separate during milling. Next comes what's often referred to as the heart of the factory, a long line of modern roller mills. In modern factories, a single production line can include 20 to 40 machines like this, each responsible for a different stage of grinding, from coarse to intermediate to fine milling. This setup maximizes both efficiency and flour quality, especially for specialty flours like pizza flour. Each pair of steel rollers spins steadily, crushing the wheat kernels and gently separating the bran, the germ, and the bright white endosperm inside. It's this endosperm, rich in starch and protein, that becomes the smooth white flour, the very foundation of a perfect pizza crust. After milling, the flour isn't ready for packaging just yet. You think those machines bouncing up and down like they've had one too many espressos? They're not dancing for fun. They're plan sifters, the unsung heroes making sure your pizza flour is smoother than your best pickup line. A large rectangular machine suspended by flexible rods, containing multiple layers of fine mesh screens. The machine gently vibrates, allowing the flour to be sorted by size with micron-level precision. Flour that meets the standard moves forward, while coarser particles are sent back for regrinding. This is the final and most critical sifting stage, ensuring pizza flour comes out consistently fine and high quality. Because with pizza, even the tiniest inconsistency can throw off the perfect crust. Next, the fine flour is transported through a high-pressure pneumatic system. Think of it as a high-speed expressway just for flour. It's carried to a cyclone separator, where centrifugal force separates the flour from the airstream, allowing for clean, dust-free, and lossless recovery. And those tangled stainless steel pipes that look like a maze? They're part of the system that delivers flour to the blending station. Here, the fine flour is given its final adjustments. Depending on the end product, enzymes, malt flour, or B vitamins may be added. Finally, after passing the last quality check for fineness and fluffiness, the flour is sent to the automated packing area. Here, every stream of fine flour is precisely weighed, filled into pre-labeled bags, and tightly sealed to preserve its freshness. Each bag typically weighs around 25 kilograms, just the right size for bakeries and food factories. Robotic arms carefully lift each bag of flour one by one, smoothly rotating and placing them neatly onto waiting pallets. The finished flour bags are then neatly stacked in climate-controlled storage, where both temperature and humidity are carefully monitored. And just like that, every pizza crust begins with a journey this meticulous. Right now, let's step into the pizza production factory, where all the anticipation truly begins. But before those golden, crispy pizza crusts hit the oven, let's take a quick detour to meet its flour-based cousin, the croissant, a pastry that also begins with the same soft white flour. The process begins with the most essential base ingredient, flour. First, a large amount of fine white flour is poured into the industrial mixing bowl, the very backbone of every croissant dough. Next comes the yeast, usually in fresh or compressed form. It's what brings the dough to life, giving the croissant its airy rise and soft texture. Then comes the cold water. Here's a little secret. To keep the dough cool and stable, especially during high-speed mixing, ice water or chilled water is often used. This helps prevent the butter from melting too soon later in the process and ensures the dough stays firm and ready for lamination. All of it goes into a massive industrial mixer, where powerful mixing arms knead the dough into a smooth, elastic mass, ready for the next act, the art of lamination. After the mixing and resting process is complete, the croissant dough moves on to a particularly crucial stage, lamination and shaping. Here the dough passes through an automated rolling system, where it's flattened and stretched into long, even sheets, as smooth and pale as ivory silk. Each sheet isn't just plain dough, it's a precise fusion of dough and butter, folded, rolled, and rested repeatedly in a process known as lamination. After every fold, the machine gently sprinkles a thin layer of flour over the surface, not only to prevent sticking, but also to ensure each layer stacks cleanly and distinctly. The alignment laser acts like the eyes of the production line, precisely positioning the dough along the programmed axis. This allows the rolling machine to shape each piece smoothly and uniformly. It's especially critical for croissants because even a slight misalignment can ruin the signature layered structure of the pastry. After being rolled into thin, the croissant dough is sent into a cutting machine that slices it into triangular shapes. However, along the outer edges of the dough sheet, excess strips often appear uneven, jagged, or fall outside the required dimensions. At this point, the automatic edge trimming system takes over. Additional side blades remove the unwanted edges, leaving each dough piece clean-cut, symmetrical, and easy to roll. After the croissant dough is cut, it moves on to the spreading stage, where each piece is gently separated and evenly arranged on the conveyor belt. Depending on the type of croissant being produced, some are rolled immediately, while others are upgraded with rich almond filling, fragrant chocolate, or savory ham and cheese. Then, intelligent rollers gently roll each piece from base to tip, creating the signature crescent shape we all recognize. The finished croissants look perfectly uniform, glossy, and irresistibly appealing, ready to head into the oven. The trays of dough now enter massive industrial ovens, where hundreds of croissants begin their spectacular transformation. At a temperature of around 107 to 190 degrees Celsius, the buttery layers slowly rise and expand. Each layer turns crisp and the edges curl upward with proud elegance. In just 15 to 20 minutes, you'll witness something close to magical. From simple rolled dough, the croissants emerge golden brown, light and airy. Then the croissants are transferred to the automated packaging area. Here they are sorted and neatly placed into bags. Each package is vacuum sealed and ready to be shipped to bakeries, supermarkets, and cafes around the world. And now comes the moment we've all been waiting for. Don't forget, we're still on a journey to create the perfect pizza. It all begins with the crispy, chewy crust, the foundation that can make or break a great pizza. Once the dough has rested long enough, it's divided into long strips and passed through rollers. Next, the dough enters the shaping and cutting stage. where circular, square, or oval cutters form each base precisely. Have you ever noticed those tiny little holes on a pizza crust? They look like someone gently poked the dough with a fork. Those holes actually help steam escape during baking, preventing the crust from puffing up or cracking. And this is where the real differences begin to show. If the croissant is a symphony of butter and layers, pizza is a playground of tomato sauce, cheese, and whatever flavors your heart desires. At this stage, the pizza crust is partially baked to set its structure, lightly dry the surface, and prevent the tomato sauce from soaking into the dough later on. Next, the tomato sauce is gently spread across the crust. This special sauce is made from ripe, juicy tomatoes blended with garlic, oregano, basil, and a touch of olive oil, creating a rich, slightly sweet and aromatic flavor that defines a classic pizza. The automatic cheese applicator operates with absolute precision. It uses fresh mozzarella, a cheese famous for its smooth melt, glossy finish, and rich texture that stays soft without releasing excess moisture. This is the secret weapon behind the irresistible appeal of every pizza. The amount of cheese is pre-measured according to specific recipes, depending on the pizza type, from classic to premium, to ensure the perfect stretch and deliciously melty richness when baked. Next, toppings like pepperoni, sausage, or bacon are automatically distributed over the freshly layered cheese. Slices of bright red pepperoni are neatly arranged, creating a visually appealing pattern and ensuring every bite is packed with rich, savory flavor. Before packaging, each pizza takes a quick trip through a gentle heating tunnel, like a mini spa session where the cheese melts just enough to hug the toppings tightly. This helps lock everything in place so nothing slides around during transport. Even better, the heat gives the surface a light sterilization, keeping the pizza fresh and safe for longer. After exiting the heating tunnel, the pizzas are moved to the packaging area. First, each pizza is tightly wrapped in plastic film to preserve freshness and maintain its shape during transport. Then, it's placed into a tray or box, labeled with product information and expiry date, and sent to cold storage for preservation before distribution. After that, the pizzas are transported to supermarkets, convenience stores, and distribution centers across the country. They are kept in consistently cold conditions throughout the journey to preserve their quality. And just like that, each fresh and delicious pizza is ready to become part of the daily meals of millions of families. If you enjoyed this video, don't forget to like, share, and leave a comment. To simplicity lovers, spaghetti can be nothing short of a tangled nightmare. But for millions of culinary enthusiasts, it's a masterpiece. Each twirl of the fork, a rich and flavorful waltz. Every single minute, over 10,000 plates of spaghetti are devoured across the globe, from humble home kitchens to glamorous Michelin-starred restaurants. But have you ever wondered how factories manage to produce millions of tons of spaghetti each year? The secret journey of these golden strands begins in the quiet wheat fields, where human hands and powerful machines work side by side to harvest high-quality grains. These grains are then transported to massive pasta factories, where state-of-the-art technology transforms them into iconic shapes like fusilli, penne, and of course, the legendary spaghetti, each strand crafted with millimeter precision. Today, join Agriculture Insight as we dive deep into the pasta universe and uncover what has kept spaghetti on the throne of the pasta kingdom for centuries. All will be revealed in this video. In the land where tender strands of pasta are revered as a national symbol, welcome to Italy, the birthplace of pasta, where over 3 million tons are crafted each year, and spaghetti rises as the shining star on every dining table. With such irresistible appeal, spaghetti has crossed borders and conquered the world. So much so that in the United States, spaghetti and meatballs has become a beloved national comfort food. Though many Italians raise an eyebrow at what they see as a fast food version that overshadows the elegance of true Italian cuisine. But no matter the version, one fact remains undeniable. Pasta is the soft gold of the global culinary world, generating over $80 billion annually and sustaining a vast ecosystem, from farms to factories, all built around the elegant twirl of a fork. Compared to instant noodles or mac and cheese drowning in butter and sodium, pasta stands out as a more balanced option, with fewer saturated fats, more protein, and endless room for fresh veggies, lean meats, and creativity on the plate. Although Italy is home to legendary pasta recipes, it's surprisingly not self-sufficient when it comes to its main ingredient. Instead, the country imports durum wheat from nations like Canada, the United States, and Australia, regions renowned for their high-quality grains and ideal protein content. And it's from these golden wheat fields that the extraordinary journey of spaghetti begins, with a humble origin in tiny grains of wheat, destined to become a global culinary icon. Every June, endless fields of wheat stretching to the horizon turn golden, as if nature is sending a gentle reminder that harvest season has officially arrived. Immediately, massive combine harvesters roar to life. Each machine stands nearly 3 meters tall and stretches over 10 meters long, rolling steadily across the straight rows of wheat. At the front, razor-sharp blades cut the stalks close to the ground, maximizing the yield with each pass. The freshly cut wheat is then pulled into the internal threshing and separating system, where high-speed rotating drums work tirelessly to cleanly and precisely separate the grains from their husks. But the job doesn't stop there. A smart filtering system continues the process, removing any remaining impurities and keeping only the best quality grains. Meanwhile, the leftover stalks, straw, and chaff are expelled back onto the field. Each modern harvester can process over 90 tons of wheat per hour, equivalent to the output of hundreds of manual laborers working at the same time. Once the grain tank is full, an automated unloading system transfers the wheat directly into large transport trucks waiting at the edge of the field. Today, modern mechanical harvesting is an indispensable part of the global food production chain. However, without strict control and the integration of sustainable agricultural practices, this process can leave behind significant environmental aftershocks, including greenhouse gas emissions, airborne fine dust, noise pollution, and soil degradation, directly impacting local ecosystems and the health of nearby communities. Once the fields are left with nothing but a golden carpet of straw, farmers begin collecting it for various uses, as livestock feed, bedding for barns, or compost for organic fertilizer. At this stage, baling machines take over, moving along the rows of leftover straw and compressing them into neat, compact, rectangular bales. To keep everything in place and prevent the straw from scattering during transport, strong binding straps are tightly wrapped around each bale, locking them into firm, sturdy blocks. Meanwhile, the trucks filled with freshly harvested wheat head off on a different journey, straight to the pasta factories, where a little bit of magic and modern alchemy transforms nature's golden grains into the world-famous strands of spaghetti. At pasta manufacturing plants, durum wheat is the star ingredient, chosen for its high protein and gluten content, which gives pasta its signature firm and chewy texture. As soon as the wheat arrives at the factory, it must pass a rigorous quality check before anything else. An automated robotic arm takes samples directly from the truck and sends them to the lab, where key indicators like protein content, moisture level, and grain hardness are carefully analyzed. If the wheat meets all the standards, it's approved for unloading and transferred into massive underground silos. These storage areas are specially engineered to protect the wheat from moisture, pests, and extreme temperatures, preserving the grain in perfect condition for the next stage of production. Once the wheat has passed inspection and is properly stored, the next step is to transform it into semolina, a coarse, protein-rich flour that forms the base of all great pasta. This transformation begins with a meticulous cleaning process. Modern cleaning systems use a combination of sieves, magnets, and air jets to remove impurities such as stones, husks, and dust. Only the clean, high-quality wheat kernels remain, ready to be milled into the golden foundation of pasta perfection. After cleaning, the wheat kernels are sent into powerful roller mills, where they're crushed and broken down into smaller pieces. With each round of milling, the crushed grain is passed through vibrating sieves that separate the bran and germ from the finer endosperm. By the end of the process, all that remains is golden semolina, rich in protein and ideal in texture, the perfect raw material for crafting high-quality pasta. Even at this stage, quality control remains a top priority. Samples of semolina are taken directly from the production line and sent to the factory's laboratory for rigorous testing. Technicians analyze key factors such as protein content, gluten strength, and other vital parameters to ensure the semolina meets the strict standards required for pasta production. Only after passing these tests is the semolina transferred into storage silos, ready for the next phase of transformation. Once the semolina passes all quality checks, the real pasta making process begins. The semolina is funneled through specialized pipes and poured directly into massive industrial mixing vats. Here, purified water is gradually added through precision spray nozzles, making up about 30 to 35% of the total mixture. This creates a rough dough made up of small, grainy clumps. While artisanal spaghetti is kneaded slowly by hand or semi-automatic machines for 20 to 40 minutes to retain natural moisture and achieve the signature chewy texture, industrial production uses high-powered machines that can process hundreds of kilograms of dough in just a few minutes. This seemingly simple step is actually the secret key behind the biggest difference between artisanal and industrial spaghetti, something many spaghetti lovers often wonder about, yet rarely notice. Next, the dough mixture is transported via conveyor belts into centrifugal sifters, specialized machines equipped with fine mesh screens that spin at high speed. These sifters filter out any remaining large clumps, leaving behind a coarse golden grain texture ideal for pasta making. To ensure the highest quality and consistency, the semolina undergoes multiple rounds of sifting, refining it further until the texture is as uniform as possible. The dough then enters the extruders, the true sculptors of the pasta world. Inside these massive machines, immense pressure is applied to force the dough through special dies made of either brass or stainless steel. Each die is precisely crafted and firmly attached to the extruder's outlet. The design of the tiny holes in these dies determines the ultimate destiny of the dough, Will it become long strands, hollow tubes, spirals, or charming little bow ties? It's here that the wonderfully diverse world of pasta takes shape, transforming a simple dough into an endless variety of iconic forms. Fusilli, the iconic twisted pasta, and penne, known for its clean, bold, and angular look, are all crafted through a combination of specially designed molds and high-pressure extrusion mechanisms, which compress, shape, and cut the dough into perfectly formed pieces within seconds. The freshly shaped pasta is then dried using a hot air system at around 80 to 90 degrees Celsius. This preserves its form without warping. Once cooled, the short pasta tubes move onto an automated packaging line, ready to be shipped and served across the globe. One of the most beloved forms of pasta is the flat, thin-cut variety, and the upcoming cutting process might just be the most satisfying thing you'll witness all day. After that, these delicate ribbons are gently laid out on conveyor belts, where they're carefully separated, lightly dusted with flour to prevent sticking, and sent off to be dried under precise temperature and humidity controls. While there are over 350 types of pasta in the world, spaghetti remains the undisputed superstar, with millions of tons produced each year to satisfy hungry forks in every corner of the globe. Unlike short pastas with twists, folds, or fancy shapes, spaghetti is simplicity at its finest. Long, round, and slender strands that look like golden threads of silk gliding out of the machine. To create this iconic form, the dough is pushed through ultra-fine round dies with absolute precision, typically producing strands between 1.5 to 2 millimeters in diameter, depending on the variety. The extruder applies consistent pressure to ensure a smooth flow, while a high-speed rotating blade cuts the strands to their perfect length, usually between 25 and 30 centimeters. After cutting, the spaghetti is automatically layered into neat stacks, ready for the drying phase. This entire process demands high-level control. Even the slightest variation in temperature or humidity can cause the spaghetti to break, stick together, or bend out of shape, ruining its signature elegance. After the shaping phase, spaghetti enters one of the most crucial stages: drying. Freshly extruded pasta still contains a high amount of moisture, and if not dried properly, it can spoil quickly. To prevent this, the strands are carefully arranged on trays or conveyor belts and moved into advanced drying chambers where hot air circulates consistently and evenly. This reduces the moisture content to a safe level, typically around 12 to 13%. After exiting the drying chambers, the strands still retain a significant amount of heat. The cooling process helps stabilize the temperature, halts further drying, and prevents unwanted shrinkage or warping, all essential to preserving the spaghetti's quality and shape. The spaghetti is cooled in a spacious, controlled environment, where fans and air conditioning systems circulate cool air evenly. Finally, once the spaghetti has passed all quality checks, it heads to a fully automated packaging system. Here, the spaghetti is portioned and sealed into individual packages with precision. Sharp blades swiftly and cleanly separate each pack, ensuring the bags don't stick together and maintaining a neat appearance. Now the spaghetti is ready, beautifully packaged and perfectly preserved, set to begin its next journey. From factory floors to supermarket shelves, and finally to the heart of kitchens and the joy of shared meals around the world. Industrial spaghetti is optimized for convenience, long shelf life, and mass production. But sometimes that very perfection strips away its artisanal soul, leaving noodles that lack character and distinct flavor. It's important to find a balance between convenience and tradition, so we don't lose the centuries of craftsmanship built by hands and hearts, all in the name of speed and efficiency.